Okay, so for this next one, example 1, all right, it says use the rectangle below. Very significant. All right, we have a rectangle. So if we look at the first one, and I'm just going to find the variables for this, guys. I'm not making my whole way through all these questions. You can do that if you want. All right, I have an answer key that is up so that you can double check your work. All right, but as of right now, I think we understand what we're doing, okay? So for this first one, we are given BD is 8y minus 4, AC is 7y plus 3. All right, those are our diagonals. Now, what do we know about the diagonals of a rectangle? We know that they are congruent. So all I'm going to do is just set 8y minus 4 equal to 7y plus 3, and then I'm going to solve. All right, so subtract the 7, add the 4. I'm going to get y is equal to 7. Okay. All right, let's do the next one. So this time we're given BC is 24 and AD is 5y minus 1. Because it's a parallelogram, I know that the opposite sides are congruent. All right, which means then that I'm going to set 5y minus 1 equal to 24. Add the 1 over, you get 5y is equal to 25, which means y is equal to 5. Okay, I'm not going to do this one right here. It's talking about vertical angles. All right, it doesn't really pertain to this lesson. Okay, so we're going to skip it. All right, so our next one, I really like doing this one so that students can kind of problem solve on their own. All right, so if we look at this example, we're given that angle 6, and I'm going to do this in a different color. All right, angle 6 is 35 degrees. And what we need to do is we need to fill in, all right, all the other angles, okay? So I think that we should be able to look at right away, all right, without any hesitations. I think we should be able to find 7, 4, and 3, okay? So to find 7, remember that it's a rectangle, all right, which means all of these are right angles. So 7 is going to be 55 degrees, all right, because if you add those two together, 35 and 55, you're going to get 90 degrees, okay? Now to get 3 is going to be alternate interior angle to the 6, all right, which means that 3 has to be congruent to that, which means that it's 35 degrees, all right, which means that 4, using that same logic, is 55, okay? So students cruise to this point, but then that kind of gets us a little stuck, okay? So what I want us to do is just quickly remember, what do we know about the diagonals of a rectangle? Well, what we know is that they bisect each other because it's a parallelogram, but we know that they're congruent, which means that all of these segments right here are congruent. Now, you're probably thinking, well, how does that help me? You're talking about segments. We're trying to find angles. Like, how is that helpful? All right, well, here's how. I want you to look at this triangle right here, okay? What type of triangle is it? It's isosceles. And what do we know about isosceles triangles? All right, what we know is that the base angles are congruent. The angles opposite of those angles have to be congruent, which means that 6 has to be congruent to 5, which means that 5 has to be 35 degrees. And if we stay with that triangle, we can find what 8 is, right? Because 8 has to add up to 180 degrees with 6 and 5. 6 and 5 added together equals 70, which means that 8 has to be 110 degrees. All right. Now, if I know that angle 5, all right, is 35, I also know that angle 2 has to be 35 because of alternate interior angles, all right, which means that angle 1 has to be 55 because it has to add up to 90 degrees. Now, 1, you could also do the same idea where this is also an isosceles triangle, which means that 1 and 7 have to be congruent, all right? Now, to find 9, that's going to be 70 degrees depending on how you do it, all right? And there, we've done it. We've filled in all the angles, okay? All right, last question of this bunch. This is a lengthy one, guys. So what we have to do is we have to determine if PQRS is a rectangle, a rhombus, and I'm actually going to add this on, or a square. All right. Now, there are multiple ways to do it. There are definitely ways that are going to be maybe a little bit quicker, all right, than other ways, okay? So what I actually want to do, all right, well, let me go through all the options, all right? So what I've had students do in the past is they've found the slope of all four sides, all right? And the significance of that is to determine if you have any perpendicular lines, so opposite reciprocals, to show that it's a rectangle, right? I've also had the students find the distance of all four lines to see if all four sides are congruent, which would make it a rhombus. All right, both of those I think are kind of a lot of work to do. All right, so what I want to do is I actually want to talk about the diagonals, okay? So if we look at the diagonals, all right, and we're going to use those same two formulas, all right, but what if I have found the slope of those two diagonals and I found that they were opposite reciprocals, which means that they're perpendicular, all right? If I did that, what would that mean? Well, that would mean that it would be a rectangle, right? Now, if I then found the distance, oh, whoa, that's not right. All right, sorry guys. If I found the slope is perpendicular, that means that it's a rhombus. How many of you guys caught that? All right. Now, if I found the distance of those sides and I found that they were congruent, all right, that would mean that it's a rectangle. Okay. But if I found that the diagonals were both perpendicular and congruent, that would mean that it has to be a square. All right. So what we're doing is we're focusing on the diagonals. Okay. So let's just kind of do a quick little sketch just so we know what our diagonals are. All right, so we're going to go P, Q, R, S. And what I'm looking at is PR and QS. All right, so what I'm going to do is I'm going to find the distance of PR and the slope of PR. And I'm going to do that for QS and I'm going to compare. Okay, so for PR and for QS. Okay. All right. So let's go ahead and find the slope of PR. All right. So I would get 1 minus 1 all over. So I did 1 minus 1 all over negative 5 minus 1, which gives me 0 over negative 6, which means that my slope is 0. Okay. I'm now going to find the slope of QS. All right. And so I'm going to get negative 2 minus 4, all right, all over negative 2 plus 2, all right, which means that that's negative 6 over 0, which means that that's undefined. All right, so right away, guys, all right, I'm going to say, well, those are perpendicular, all right, which means that it has to be a rhombus or a square, right? So we have perpendicular slopes. So now, in order to determine if it's a rhombus or a square, all right, we now have to look at the distance of it. Okay, so now I'm going to find the distance, all right, of those two sides. Okay, so let's find the distance. So the distance of PR, I'm going to do 1 plus 5 squared plus 1 minus 1 squared. All right, which gives me the square root of 36. Which is equal to 0. Nope, which is equal to 6. Holy cow. All right. I'm now going to find the slope of QS. I'm messing up. I'm going to find the distance of QS. All right. And so I'm going to do negative 2 plus 2, which is 0, obviously, squared, plus 4 plus 2 squared. All right, which gives me the square root of 36, which is equal to 6. So my diagonals are also congruent, all right? And so now that I have diagonals that are both perpendicular and congruent, that means it is a square. All right, I'm going to pause there and then we'll come back with rhombi.